We're now going to talk about statistics. As you can see from this definition, statistics encompasses a lot of different things having to do with what we do with a bunch of information. So statistics includes collecting the information, how we go about gathering the data, organizing the information. Once we've collected all this data, what do we do with it? How do we compress it? Summarizing it, and analyzing it to draw conclusions or answer questions. In addition, statistics is about providing a measure of confidence in any conclusions. So we can say, okay, we think that this data means this, and we're very sure about it, or we're less sure about it. In this class, we're particularly going to be concerned with descriptive statistics, which consists of organizing and summarizing data. And as we're going to see, we're going to be describing our data through numerical summaries, tables, and graphs. The entire group of individuals to be studied is called the population. An individual is a person or object that is a member of the population being studied. However, often the population is too big to actually study the entire population. We could be talking about thousands or even millions of individuals. So often what we're going to do is we're going to take a sample, which is a subset of the population that's being studied. A parameter is a numerical summary of a population. A statistic is a numerical summary based on a sample. So you can use a little bit of alliteration here to remember that parameter goes with population and statistic goes with sample. So here's an example of what we mean by that. Suppose the percentage of all students on your campus who have a job is 84.9%. This value represents a parameter because it's a numerical summary of a population, right? So the population is all of the students on the campus, and 84.9% actually tells you what percentage of all the students actually has a job. Now suppose a sample of 250 students is obtained. So this is not all the students on campus, this is a smaller sample. And from this sample, we find that 86.4% have a job. This value represents a statistic because it's a numerical summary based on a sample. So of the smaller sample, 86.4% have a job, that's a statistic. But if you actually go to the whole population, we see that 84.9% have a job, and that is a parameter. So parameter, population, statistic, sample. Variables are the characteristics of individuals within the population. So the whole point is that variables are called that because they vary. So one example is the variable height. If all individuals have the same height, then obtaining the height of one individual would be sufficient in knowing the heights of all individuals. But of course, this is not the case. As researchers, we wish to identify the factors that influence variability. Now, we're going to start breaking down the different variables that we could potentially look at into different categories, different types of variables. The first division that we're going to look at is qualitative versus quantitative. Qualitative, or categorical variables, allow for classification of individuals based on some attribute or characteristic, whereas quantitative variables provide numerical measures of individuals. Arithmetic operations, such as addition and subtraction, can be performed on the values of the quantitative variable and provide meaningful results. So qualitative, you're just putting people or things into categories, and quantitative is you're actually assigning a numerical number in a way that means something. So for example, eye color is a qualitative variable. We're just going to put people into categories based on their eye color. Blue, brown, green, hazel. Each person is assigned a category, but then there's no numbers that are really associated with it in a way that would make any sense. Whereas quantitative would be something like height. We assign people to a certain height, and that height is a number. And the numbers aren't just randomly assigned, they actually make sense, and we can do arithmetic operations on them. For example, if we subtract the height of person A from the height of person B, we get how much taller is person B than person A. It actually makes sense to be performing an arithmetic operation on these numbers. Whereas something like a phone number is still qualitative because the numbers don't have numerical meaning. Even though numbers are used, it wouldn't mean anything to add two people's phone numbers together. So just because something uses a number doesn't mean that it's quantitative. You really want to be asking yourself, does it provide a numerical measure? Now, as you can see on the bottom here in this diagram, quantitative variables can be broken into two different kinds, discrete and continuous. Now, a discrete variable is a quantitative variable that has either a finite number of possible values or a countable number of possible values. So the term countable means the values result from counting, such as 0, 1, 2, 3, etc. A continuous variable is a quantitative variable that has an infinite number of possible values it can take on and can be measured to any desired level of accuracy. So what you really want to be asking yourself if you're trying to figure out if a variable is discrete or continuous is there a next number? So for example, if you are counting the number of people in the room and there's 49, if there were more, it would jump all the way up to 50. But if you're counting the amount of water in a cup, for example, let's say you've got exactly 4 ounces, and you say, I want to add more water, you're not going to necessarily jump all the way up to 5 ounces or even 4.5 ounces. It could be 4.1 ounces or 4.01 ounces or 4.001 ounces. There's no kind of next level that you would automatically jump to. So that's what makes the amount of water in the cup continuous, whereas the number of people in the room is discrete. Now, the list of observations a variable assumes is called data. So just to give you a sense of how we use the different terms, while gender is a variable, just like height is a variable, eye color is a variable, the observations, male or female, are data. And then we have all these different types of data which go along with the types of variables. So qualitative data are observations corresponding to a qualitative variable. Quantitative data are observations corresponding to a quantitative variable. And then, of course, that can be broken down into discrete data and continuous data. We're now going to talk about another way of distinguishing between different types of variables, and that's by levels of measurement. First, we're going to have variables at the nominal level of measurement, and this is going to be if the values of the variable name, label, or categorize. In addition, the naming scheme does not allow for the values of the variable to be arranged in a ranked or specific order. When you think of variables at the nominal level of measurement, you want to be thinking of something like favorite food. So the values the variable can take, pizza, watermelon, coffee, don't have any intrinsic order to them. They could be listed in any order and it would make just as much sense. Now, a variable is at the ordinal level of measurement if it has the properties of the nominal level, meaning the variable still puts things into categories, but the naming scheme allows for the values of the variable to be arranged in a ranked or specific order. So here, for example, you can think of a survey where there's a statement and you're asked if you strongly disagree, neutral, agree, or strongly agree. The answers make sense in a specific order. And it makes sense to say, for example, that agree falls somewhere in between neutral and strongly agree. Now, a variable is at the interval level of measurement if it has the properties of the ordinal level of measurement and the differences in the values of the variable have meaning. A value of 0 in the interval level of measurement does not mean the absence of the quantity. Arithmetic operations such as addition and subtraction can be performed on the values of the variable. First of all, notice here that our variable actually has to be taking on numerical values. So here we're definitely talking about a quantitative variable. So what does it mean that a value of 0 in the interval level of measurement does not mean absence of the quantity? So what you want to be thinking of here is something like the year. So for example, the year 0 doesn't mean that there isn't a year. It's just that's where we decided 0 would be. However, something like subtraction does make sense. If we say 2013 minus 2000 is 13 years, that actually does make sense. Finally, a variable is at the ratio level of measurement if it has the properties of the interval level of measurement and the ratios of the values of the variable have meaning. So a value of 0 in the ratio level of measurement means the absence of the quantity. Arithmetic operations such as multiplication and division can be performed on the values of the variable. So let's go to this line. The ratios of the values of the variable have meaning. So what you want to be asking yourself here is, for example, does it make sense for me to say this doubled? So for example, height. If someone at a certain age is 3 feet tall, and then by full grown this person is 6 feet tall, you can say the height doubled. And that really has meaning. And that's really because a height of 0 actually means that there is no height. So this is a variable at the ratio level of measurement. And again, the things we want to be asking ourselves is if the value is 0, does that actually mean that there is nothing? And the other thing we want to be asking ourselves is, does it make sense to say that this doubled, or this cut in half, or this tripled?